Welcome to tutorial 2.9 part 1. This is on formulas for organic compounds. So this is like the very beginning of organic chemistry. We're just going to touch on it so that we can reference these molecules in the class, but we're not going to go very far with this at all. So first of all, here's a picture of a few of the simplest organic molecules. This very simplest class here is called, these are called hydrocarbons, because they only consist of carbon and hydrogens covalently bonded, and we're only going to look at single bonded carbons. They're also double and triple bonded. So let's look at these and see if you can kind of get a pattern here. First of all, these names on the left, the names shown here, those you have to memorize. So when there's one carbon, it's called methane. If it's two carbons, ethane, three propane, etc. And we'll just practice memorizing that together in class a little bit. But kind of look at the pattern of how these formulas work. Remember, every carbon is going to have 4 bonds around it. So how I like to think of it is that I think of every one of these simple hydrocarbons as having a carbon with a hydrogen above and below, even though this is just a two-dimensional representation. So above and below the plane as represented, and then on the caps, on the outside, another two hydrogens. For methane, this doesn't quite make sense. But look at this next one. Think of this carbon here, hydrogen above, hydrogen below, hydrogen above, hydrogen below, and then the 2 for the cap. So what that means is you're always going to have double the number of hydrogens as carbons, because it's 1 above, 1 below, and then add 2 to that. So if you want to know the number of hydrogens without counting them all, C2H6 would be what? Double the 2, that's 4. That's because the one's above, below, plus the 2 for the kind of ends. See that if the pattern works here, 2 times 3 is 6. That's how many hydrogens you have, plus 2 more at the end. So here they are, 3 carbons, hydrogen above and below, so C3H8 is the formula. These keep working the same way, butane, pentane, hexane, etc. Always double the number of hydrogens as carbons, plus 2 for the ends. When we get at the end to the end, there's a few more here to look at. What happens if you put these things called functional groups with these alkanes? So this group here, this OH group, is going to turn this particular alkane into an alcohol. And this particular one is called methanol. So notice the structure of the name. Methane, when you have this OH group in the place of that hydrogen, is called methanol. Ethane becomes ethanol. And then slightly more confusing, what happened here? What's with that 1? Propane doesn't just become propanol because we have a choice of where to put that hydroxyl group. We could put it at the end. The left and the right ends would be the same. So on this carbon, we would still call it 1-propanol, or if it was over here someplace, or for that matter, on this hydrogen or this hydrogen. But if it was in this middle section, it would be on a different carbon. And then we would refer to that as 2-propanol, where the oxygen is. The formula for these are actually pretty straightforward. This is just the same formula as the alkane, CH4, and then just add an O to it, because it's kind of like this O had kind of slipped in between where the carbon and the hydrogen was initially. It's not the structure of how it's made or the mechanism, but you can think of it that way to help you keep track of the formula. There's another group, these halogens, when they form with alkanes, are also very common. One slight difference here, the bromine is going to replace one of the hydrogens. So instead of having C2H6Br, the way it would have been for oxygen for the alcohol, it's C2H5Br, one less hydrogen because the bromine is in the place of that. Again, if the bromine in this case is attached to the first or the second carbon, make sure you indicate it with 1-bromo-propane, for example, or 2-bromo, depending on where it's attached. All right, that's a good kind of overview. Now let's kind of look at a few of these on the slides and see if we can kind of manage them. We'll do it nice and slowly. First of all, what's the formula for methane? Pure memorization. You just have to remember it's CH4. Once you have it, though, and you kind of see it in your mind, if I ask the next question, what's the formula for methanol? You say, oh, I know that one. That's just methane with this extra oxygen attached. So I would just say CH4O, and I would just stick the oxygen between any of these carbon hydrogens. It doesn't matter which it is. As the molecule would rotate, it would still be the same molecule. So methanol is CH4O. Again, the last type is also easier. Chloromethane, you say, oh, I know that chloro, that means that chlorine is attached. There's just one of them. It doesn't talk about it being more than one. So chloromethane, you could just say the place of this H, put a Cl, but remember this time you're going to have to drop out one of those H's. So it becomes CH3Cl rather than CH4Cl, the way it would have been if we had formed an alcohol. All right, that's the pattern we're going to follow in this little mini tutorial. I'll give you a compound from pure memory, and then we'll try to make some of these alcohols and these halogen compounds. Okay, let's look at this one. What's the formula for ethane? It's pure memory, C2H6. That's what it looks like. However, once you have that one down, if I ask what ethanol is, you go, oh, I get that. Put an O in between here. So it just becomes C2H6O for ethanol. The next type is also easy once you know ethane. Chloroethane. Oh, I'll just put a chlorine in the place of one of these hydrogens. Which one doesn't matter. So it becomes what? C2, not H6Cl, but C2H5Cl, because the Cl replaces one of those hydrogens. Good. I hope you're seeing the pattern. Let's try another one. Propane. Remember, this is the one with 3 carbons, though, so we're going to have to distinguish where we put the alcohol, the hydroxyl group, or the halogen. All right, so first of all, by memory, what's propane? C3H8. That you just have to remember. But once you remember that, question what's 1-propanol. And you go, oh, I know what that 1 means. The hydroxyl group, that oxygen I add, has to be on that first carbon. Either was this one to the far right or that one on the far left. So what's the formula? C3H8O, the O being the oxygen, and the structure of it would be shown on the far right-hand side. So then what would be 2-propanol? Well, the formula, the molecular form is the same, C3H8O, but this time I have to stick the oxygen on this second, or that middle carbon. So it's C3H8O as before, but the oxygen is sitting on the middle. Let's try adding these halogens. 1-chloropropane, same deal. Got to put the chlorine in the place of one of these hydrogens, so it becomes C3H7Cl, not 8, C3H7, and it's stuck there. That's if it's on the end carbons, the first one or the end one on the other side. If it's in the middle, it's going to be called 2-chloropropane, C3H7Cl again. The molecular formula isn't any different. We're pretty close to being done with these, but now let's look at something else. How do we figure out how to write the formula for acids? Now, acids are a little bit different. We're going to base them upon the polyatomic ion associated with the acid that we looked at a couple of slides ago, a couple of tutorials ago. Nitric acid leaves behind the nitrate ion. So what you do for nitric acid, you look for the nitrate ion, there it is, NO3-, and add as many hydrogens that are needed to make the charge neutral. So the formula for nitric acid is HNO3. All right, let's try another one of those. Hydrochloric acid. This time it's not shown, it's not a polyatomic ion. When it has this hydro in the front, what that means is that the chloride ion, which is a -1 charge, has 1 hydrogen associated with it to form the HCl, or hydrochloric acid molecule. Sulfuric acid. Sulfuric acid is based relative to sulfate, SO4 with 2 minuses. Since there's 2 minuses, we'll need 2 hydrogens. So the formula for the acid is H2SO4. And 1 or 2 more carbonic acid, CO3 2 minuses is here. So I need 2 hydrogens, that's H2CO3. And then a couple, 1 or 2 more hypochlorous acid, I guess is the last one. Here's the hypochlorite ion. So the acid would be HClO. Okay, so that's all there is for these. So I think the acid naming we're going to have to do nice and slowly in class. That was obviously way too rushed to be anything other than just a quick, kind of review. We'll do those nice and slowly. But the other ones, I think those organic molecules, the pattern that you saw in the tutorial might be enough to kind of get you through the quiz. So good luck with this. Try on your own. Look at the acid section together, or let's talk about the acids together slowly in class. And the rest of the stuff, I think you'll be able to manage just fine. All right, good luck with this. We'll see you in class.